Good morning, everyone. This is Sam Cheng. I'm a biodiversity scientist at the Center for Biodiversity and Conservation at the American Museum of Natural History in New York City. Apologies, I could not be with you live today, but I'm looking forward to hearing your questions after this webinar. So today I'm going to be talking about machine learning and open source technologies, specifically talking about some of the lessons we've learned from developing and running Colandr, which is an open source, open access platform for evidence synthesis. So currently researchers depend on manual approaches for sifting through the piles of information and documents that we look through for conducting evidence synthesis. Unfortunately, many of these approaches that we currently use are quite inefficient. So in this case, the authors of systematic maps and reviews in environmental topics within the Journal of Environmental Evidence are reading on average 14,000 citations to search for what they need, ultimately only including about 2.4% of what they examined. So not only is this manual process inefficient, it's also quite labor intensive. So this raises significant resource challenges to ensure that reviews are properly staffed. Estimates of the cost of systematic reviews, for example, range anywhere from $30,000 to $300,000 US, and depending on the scope, can take several years, which can be a challenge when producing syntheses that intend to respond to decisions and challenges with relatively short timelines. So the reality of the synthesis process is that as the evidence base is constantly growing, reviews will need to be updated. So with such an onerous process, what we actually need is a dynamic way to actually be able to search and to filter and to extract data to keep up with the pace of scientific research. So machine learning technologies can present a very exciting potential for solving some of these problems. In particular, machine learning approaches can be used to help us classify text. So taking unlabeled documents, whether these are citations or papers, and turning that text into vectors. And essentially what this allows us to do is use this to calculate the probability that this text is relevant to our topics of interest. And we can classify them as included or excluded. In addition, we can use specific types of natural language processing algorithms such as GLOVE, which is a global vector, that can capture the probability of given words given the presence of other words. So essentially reading the text for us and determining whether or not it's relevant for our topics based on how these words are arranged in a sentence. So, we came at this with this question of how do you then tackle large systematic maps where you're trying to go through a lot of different types of information within a broad topic area? And then how do you actually dynamically update these syntheses? So in a collaborative effort led by the Science for Nature and People Partnership, Working Group on Evidence-Based Conservation, with DataKind, which is a data science for social good nonprofit, along with Conservation International, a international NGO for conservation, we developed an open access, open source application for evidence synthesis that's powered by machine learning and natural language processing in order to make the process faster and to make it more efficient. So Colandr is supported and hosted by the Center for Biodiversity and Conservation at the museum. So Colandr uses computer assistance at two stages of the evidence review process. First, it helps users find relevant evidence faster by employing a machine learning process that dynamically learns what is relevant to the individual user and intelligently sorts citations by their relevance. Colandr then employs machine learning and natural language processing to assist users with sorting and labeling of relevant documents. The platform has several features. It's built on an open science principle, so the code is open source and is available for future community development. It was built to facilitate collaborative synthesis by teams. So it's online and it's free and allows for unlimited users per synthesis project. So while the origins of Colandr are within the conservation sector, it works actually for any domain of knowledge. So we built Colandr to make the synthesis process faster, but also to ensure that the process remained transparent, and we continue to try and minimize bias in the process to ensure reliable syntheses. So Colandr is actually a semi-automated system that retains user oversight for all final decisions on relevance or for sorting. Lastly, the output of Colandr projects can be exported for use in other programs. We have an active community of users and many online resources on our community website. And for those that are interested, Colandr's framework is built using open source languages and packages, which are listed here on the right-hand side, and more details can be found on our GitHub page. So I just want to take you through a brief walk of Colandr and its functionality. Once you sign up for an account, you can set up a new review, which will have a homepage that looks like this. You can plan and organize your review up top, as well as put in your key terms, selection criteria, and extraction form that will inform the machine learning model. You will also see that your review is broken down into 3 stages: citation screening, from which the included articles will go to full text screening here, and then the final included articles will then proceed to data extraction, where you will label your documents. You can invite as many people to your review as you like and choose whether or not you want your documents reviewed by more than one person. So Colandr uses machine learning in 2 systems. In system 1, the user imports citations into the platform. Colandr then ranks these citations based on the presence of user-defined key terms. So these are your search terms. Users then go through these citations, coding them as included or excluded. And after the user has gone through at least 10 citations, the machine learning model reruns based on this input and re-ranks the list of citations based on relevance. So this is a dynamic, iterative process, so the more user reviews, the more accurate the relevance ranking will become. So specifically, what we do in this stage is we employ an algorithm called word2vec, and this identifies co-occurrences of words around your key terms that you see in bold here. So essentially it reads the abstracts and determines relevance, and then users can choose to include or exclude the listed citations. So after users have screened their citations and come up with their final list of included document, so this is passed through full text screening, System 2 predictively labels articles based on user-defined categories. So for example, in this case, our user-defined categories are for labeling documents for a synthesis on conservation actions and impacts on human well-being. So users import PDFs, which are then converted into text. Then users must manually label 50 articles before the machine learning algorithm begins to predictively label the articles. In developing Colandr, we found that because disciplines differ in how much semantic variation, so how much words differ, how many different meanings a single word or phrase might have, because of this variation that exists to describe different types of topics and categories, that a more universally useful methodology here was actually to display the sentences in the document that best predict the labels with confidence rankings instead of automatically sorting and labeling documents without any user oversight. So users would then choose the correct labels, and again, this is a dynamic process, so the model is constantly learning and refining the predictions. And then finally, the resulting data set and coding decisions can be exported for analysis in other programs. So you can see what this looks like in practice with sections of the text that Colandr predicts are relevant for a specific label, and users can approve or reject those. So Colandr currently has over 1,500 users. These are users who have about 1,200 active reviews in a variety of topics, for example, in conservation, environment, ecology, economics, and in medicine and education. So Colandr's users are quite a diverse crowd. Some examples include the ISEAL Alliance, who's been using it to extract information on the impacts of certification, the American College of Physicians, who is interested in using the underlying algorithms to improve synthesis in medicine, and then within the Science for Nature and People Partnership itself, by providing a tool for ongoing working groups such as ecological drought, soil carbon, and ecological lovers for health to find and to synthesize evidence to inform research and practice. So one question we often get from Colandr users is, when can we actually stop? Because this is an iterative, active learning, machine learning process, the tool does not automatically sort citations into included and excluded. So users are constantly going through a list of unscreened citations and sorting through them. So because Colandr doesn't provide you with hard stopping points, as well, within the evidence synthesis community across multiple disciplines, not just environmental sciences, there's a little guidance on when we can actually stop screening. And when we look at the possibilities of what we might risk by stopping screening too early, or the resources that might be wasted by screening too many irrelevant citations, we can try and start to make decisions about what are appropriate stopping points by determining what the level of acceptable risk is for the type of decision that the synthesis intends to inform. So, for example, thinking about, well, what is risk by missing evidence? How much evidence can be missed? And for us to still trust the process. And this will obviously depend on the type of decision, the urgency of that decision, the decision timeline, and various other factors. So while we can't provide you with any hard stopping points, what we can do is provide you with a tool to monitor your progress and track what is happening in your review in real time. So the Colandr Companion is available as an open source R-Shiny application. And you can visit it and input your review ID and your email address that's associated with that review. And you can do things like track your inclusion rate for your review. You can also do things like looking at your inclusion rate over a certain interval of total citations screened. For example, many reviews have been employing different types of metrics, for example, such as not being able to find, not finding any relevant citations. After having screened a certain number of citations, they would deem that time to stop. You can also look at progress for individual users to see how many citations each user has screened. Colandr also has a feature where you can add tags to citations into full text as sort of preliminary ways to mark documents. And you can look at summaries of the tags applied for both included and excluded in all the citations that have been screened. As well, you can export bespoke data sets. When you use the export function in Colandr, it exports one set of columns of your data set. If you're interested in other columns that are not traditionally exported, you can choose to export them here. And you can also export your citation files. So your included or your excluded title and abstract, and as well as full text. And you can export that as a RIS file. So the second part of this talk is looking at what this means for building open source apps and what we've learned from the Colandr process. So on the one hand, because Colandr is open source, it provides us a really great opportunity for crowdsourcing innovation. So for example, Colandr community users have built add-ons and tools that complement and enhance Colandr's functionality. The second is the opportunity for Colandr to contribute to progress in machine learning and evidence synthesis. So by sharing this innovation, we built Colandr at a time when other machine learning softwares and platforms also existed. But those processes often weren't particularly transparent. And so what we aimed to do was develop an active learning model that allowed for more user oversight. But this really is just the first step. There are many different ways forward for machine learning and evidence synthesis to progress. So we want what we have done to contribute to this. And so hence this is our commitment to an open source platform. But at the same time, this comes with many challenges. Colandr was built by a team of volunteer data scientists. So this team of 4 built Colandr in their own time, in nights and weekends, over the course of 18 months. So currently, one of our challenges is figuring out how do we actually maintain Colandr? How do we provide our users with support? How do we troubleshoot when the server goes down? How do we maintain hosting costs? And we've been able to do this through a combination of philanthropy and different types of funding strategies through our various institutional partners. But this is something that every open source software should be thinking about, is once you've built your tool, how will you maintain it in the long run? As well, another challenge is keeping up with developments. Software is always changing. Language is always changing. Bugs pop up. There are new versions, people requesting, new developments to improve the tool. And so how do we do that when development time is costly at times and our tool is free to use? And this is something that we're still grappling with. One thing that Colandr as an open source platform has allowed us to really think about and to interact within the open source community around is to think about what the evidence pipeline could look like. So by creating a platform where there are interoperable inputs and outputs, they can come from other programs, they can be fed into different other programs, and trying to facilitate cross connectivity between these different applications, what we're actually seeing is an open source, a commitment to open source principles can maximize the potential of this entire landscape of tools that's emerging, rather than trying to build one do-it-all platform. And through our growing community of users, this network, through the evidence synthesis technology group, we're seeing a lot of potential for this moving forward. So with that, I will not be taking any questions, obviously, but I welcome any questions to be sent to my email or to the Colandr team email address. And please do feel free to visit the app, the community website, as well as the Colandr companion website. Thank you.